So in this video, I'm going to introduce you to the method of partial fraction decomposition, which allows us to write a rational function where the denominator is a degree lower than the numerator as a sum of fractions where each denominator is a linear factor. So you were supposed to cover this technique in pre-calc, but my understanding is because of the pandemic it was skipped. So I'm going to expect you to learn and practice this on your own and to have this knowledge when we start covering this technique in a week or so. So here's an example. So here we have 2x minus 3 divided by x squared minus 5x plus 6. So first step is to factor the denominator, and we have 2x minus 3 over x minus 2 times x minus 3. Those are the factors. And what I assert is this can be written as some number a over x minus 2 plus some number b over x minus 3. So we're just going to assume that that works. It always does. I'm not going to discuss why, but I'm just going to show you how we find a and b. So we're going to take advantage of the fact that these two expressions have to be equivalent, right? So we're going to write it over here. And I'm going to multiply both sides by the denominator, and we get 2x minus 3, the left side denominator, equals a times x minus 3 plus b times x minus 2. And now I'm going to take advantage of the fact that these two expressions are going to be equivalent for all values of x because they're equivalent expressions. So usefully, they'll be equivalent for the zeros of the linear factors. And we're just going to plug those zeros in. So what do we get when x equals 3? Well, on this side we get 6 minus 3, or 3, equals, we plug in 3 into a times x minus 3, we get 0. B times 3 minus 2, or just b. So b equals 3. And then we'll do the same thing for x equals 2. So when we plug in 2 into 2x minus 3, we get 4 minus 3, which is 1, equals, so we plug in 2 here and we get a times negative 1, and then b times 2 minus 2 is obviously 0. So we get that a equals negative 1, which means that this fraction here, 2x minus 3 over x minus 2 times x minus 3 equals negative 1 over x minus 2 plus 3 over x minus 3. So just so you can see how this works, we can check this expression and see that they're equivalent. Okay, so let's just take this and put them over a common denominator. So we're going to get 3 times x minus 2 minus 1 times x minus 3 over x minus 3 times x minus 2, and this just equals 3x minus 6 minus x plus 3 over x minus 3 times x minus 2. So this equals 2x minus 3 over x minus 3 times x minus 2. Okay, so now I have one for you to try. So use factoring by grouping to find the factors of the denominator. You can pause here and try it on your own. Okay, so now I'm going to solve this. All right, so here we go. So this equals 4x plus 7 over x squared times x plus 3 minus 1 times x plus 3, which means this is 4x plus 7 over x squared minus 1 times x plus 3, which means this is 4x plus 7 over x minus 1 times x plus 1 times x plus 3. So now we know that that means it equals a over x minus 1 plus b over x plus 1 plus c over x plus 3, which means 4x plus 7 equals a times x plus 1 times x plus 3 plus b times x minus 1 times x plus 3 plus c times x minus 1 x plus 1. Oop, went out of space there. Okay, so now we're going to try the values 1 and -1 and -3. So let's start with x equals 1. When x equals 1, this expression here is just 11. And when x equals 1, this is a times 2 times 5, or 10. And the other two expressions, sorry, not 2 times 5, 2 times 4, or 8. The other two expressions are 0, so a equals 11/8. Now we're going to try x equals -1. When x is -1, the expression on the left side is 3. And then this cancels, and this one cancels, and we're just left with b. And b is going to be -2 and 2, or -4. So b equals -3 over 4. And now we're going to try x equals -3. So when x is -3, this side is -5. And when x is -3, we just have c. And we have -3 minus 1, or -4, times -3 plus 1, or -2, or 8. So c equals 5/8. So that means that we can rewrite this expression as 11 over 8. Hang on. 11 over 8 times x minus 1 minus 3 over 4 times x plus 1 minus, so that's a -5/8, 5 over 8 times x plus 3. Okay, so now there's one small now these problems can get very complicated if they're quadratic numerators or even quadratic denominators, but we don't need to deal with those situations in BC. But we do have to deal with the situation where there's a repeated linear factor, and a linear factor squared or cubed, mostly squared. And the way that it works is if we have a linear factor, which is, just going to give an example, let's just do a really simple one. 1 over, let's say, let's say x plus 1 over x cubed times x plus 3, then this is going to have to be a over x plus 3, and then also plus b over x plus c over x squared plus d over x cubed. So there's basically one term for every power of that factor in the denominator. So let's do an example. And here's an example right here. Phi fx minus 9 over x minus 4 times x minus 1 squared. So this is going to equal a over x minus 4 plus b over x minus 1 plus c over x minus 1, whoops, squared. So now we multiply both sides and we get 5x minus 9 equals a times x minus 1 squared plus b times x minus 1 times x minus 4 plus c times x minus 4. So we use the same technique for the most part. So first we plug in x equals 1, and on this side we get negative 4, and these two factors cancel out, and we end up with c times negative 3, and so c equals 4/3. All right, now we're going to set x equal to 4. And when x equals 4, this is going to be 5x minus 9 is going to equal 11. And on this side, we get 4 minus, these b and c terms cancel out, and we end up with 9a, or a equals 11/9. Okay, now you say, look at this, we're all out of zeros. Well, we asserted that this is true for any value of x. So it is true for 1 and it's true for 4, but it's also true for any other x we could choose. So we're going to choose 0. So I'm going to say x equals 0, and we're going to plug in the values that we already have for a and c, and this will allow us to solve for b. So when x equals 0, the left side of the equation is negative 9. And then we have a is 11/9 times 1 plus b, which we're trying to find, times 4 plus c times negative 4. Oh, sorry, but we know what c is. Hang on a second. Just going to erase the c. Okay, so we know that c is 4/3, right? And 4/3 times negative 4. So this tells us that negative 9 equals 11/9 plus 4b minus 16/3. So it's a little bit ugly, but when we do the arithmetic, which I'm not going to do in detail, we end up with 4b equals 44/9. So b equals, negative 44/9. So b equals negative 11/9. So then our partial fraction decomposition, let's just write our numbers up here so we can see. We have a is 11/9, b is negative 11/9, and c is 4/3. Okay, here's one for you to try. Pause and try it on your own. Okay, now I'm going to show you the answer. So we get 5x plus 3 over x plus 2 is going to equal a times x minus 2 plus b over x plus c over x squared, which means that 5x plus 3 equals a x squared plus b x times x minus 2 plus c times x minus 2. So first we'll try x equals 0, and we get 3 equals c times negative 2, so c equals negative 3 over 2. And then we'll say x equals 2. And that'll give us that 13 equals 4a, or a equals 13/4. Okay, so now again, we have to pick another number other than our 2 zeros to find out what b is. So let's choose x equals 1. So when x equals 1, we have 8 equals a, which is 13/4, times 1 squared, so that's just 13/4, plus b, which is going to be 1 times -1, or just b times -1, plus c, which is -3, or let's just do minus 3/2, times 1 minus 2, which is -1. So we have 8 equals 13/4 minus 3/2 minus b. So now we just have to solve this for b. Okay, so this is a -3/2, not a +3/2. And then when we solve this for b, we get b equals 13/4 plus 6/4 minus 32/4, which is -13/4. So then I'm just going to write our answers up here. We have a is 13/4, and b is -13/4, and c is -3/2.